That's algebra. And then number 2, we have what we call the sequences and the series. Okay. And then number 3, after the sequence of series. So usually algebra will have something like 1 question. Sequences and series, it could be a range, but maximum or minimum is usually 2 questions. Number 3, we have what we call the functions. So these functions, remember, we have quite a number of functions, okay? You have the parabolas, we have the hyperbolas, the exponentials, and all of them, okay? So with these functions, it's possible to have, because now that is question 1 up to 3, then probably question 4 and 5. So this is also 2 questions. Okay, but this depends on the examiners, okay, what they feel, how many questions should be per topic, okay? Then from the functions, we have what we call the finance, and finance is usually 1 question, okay? Then besides the finance, we have the next topic, which is the calculus. Calculus, and this one is also around about 2 to 3 questions, depending, okay? Because we have the optimization and all of that. So I'll just give it around about 3 questions, or 2 to 3. And then lastly, we have probability. So this probability is usually a question or basically 2. So depending on what the examiners really wanted to test on. But just try to follow the mark allocation of each and every topic, okay? So like with the first topic, we usually have 20 plus minus marks, okay? So I'm just gonna use this paper just as a guide in our discussion for this paper 1. Okay, so we have 10 pages here, and how many questions? We have 10 questions in this case, but it's possible to have 11 questions. 12, not really. Okay, let's see. Question number 1. Algebra, which is solve for x. Now with this, we have x, open brackets, x plus 3 is equal to 0. For as long as we have brackets, x plus 4 or x minus 2 is equal to 0. So this represents what we call the dot product. And with the dot product, it's all about getting each term and then equating it to 0, meaning that this first part, x is a 0, or this bracket equated to 0. And then you solve for x, meaning that x is going to be a negative 3. So this only works if we have a 0 at the end. If ever we have a number other than 0, then you have to open up the brackets this side and then you solve, okay? Now question 1.1.2. Wherever we see this condition of correct 2 decimal places, just know that we're gonna use the quadratic formula. So step number 1, we need to create the standard form or the standard equation, whereby everything should be on one side and then 0 should be left on the other. So we're gonna have 3x squared, okay, minus 4x minus 5 gives us a 0. Okay, so you'll get a mark for just showing us that. Now from here, we know that our A is a 3, our B is a negative 4, a number with its sign. And then the C is gonna be a negative 5, number with its sign. And then write down the quadratic formula, negative B plus minus is divided by 2A. Let's substitute, so a negative and negative, that's gonna give us a positive 4 plus minus square root of negative 4 squared minus 4 into 3 times negative 5 divided by twice 3. Okay, so for as long as we've showed the equation, the substitution part, the next part should be just the answers. put this in the calculator. So my first x value is a 2,12, or x is a negative 0,79. So we always prefer 2 decimal places because that was the condition. All right, then 1.1.3. This is an equation with a surd form or with a surd. So there's a square root somewhere. Step number 1 is always isolate the root sign. So in this case, it is already isolated. In other words, it's being left on one side of the equal signs. For cases where probably it was going to be maybe 5 minus x minus 1 is equal to x, you have to first move this one to that side before you apply the squaring. Okay, so let's use this page and we square. This is 1.1.3. So everyone should at least aim towards getting the full marks for the first question. Say x plus 1. Okay, plus gonna be a 2x plus a 1. So these are just square brackets, x plus 1, and then x plus 1. Then you apply your FOIL. Okay, so just on this note, sometimes if you have a negative here, automatically that negative is going to become a positive. Okay, now, as much as it's a bit tricky, if let's say we had a number in front here, so that if it's maybe a 2 square root of 5 minus x, if we square that, these 2 must affect these 2, so that you have a 4, open brackets, 5 minus x, and then you proceed. Okay, from here, let's collect the like terms. Everything should be on one side to form a standard equation. It's x squared plus 3x, that's going to be minus 4 is equal to 0. I'm moving everything to the right. Then I can factor this out. I can use the quadratic formula, meaning that my sum is a positive. So that's a positive 4. And then my product is a negative. Okay, meaning that either x is a negative 4 or x is going to be a positive 1. Now, most people or most learners tend to stop here. You're going to lose a mark. Okay. The last step in this sort of equation is you have to test your answers, these values of yours. So by testing, it simply means that just get these numbers and try to substitute into the original expression. Okay, so in this case, our original was just 5 minus x is equal to x plus 1. So you don't have to show us this step of testing. Okay, just use your calculator, punch these numbers back. If the left-hand side gives you what is on the right, then that's the solution we need. If it doesn't, then we kick it out. So let's start with the positive 1. So 5 minus 1 is going to be a 4. Square root of 4 is going to be a 2. And then 1 plus 1 gives us a 2, which means this solution is valid. Let's try with negative 4. So 5 minus minus 4, that's going to give us the square root of 9, which gives us a 3. On the right-hand side, negative 4 plus 1 gives us a negative 3. These two are different. So we cross this out, or you can say it's not a solution or something like that. For as long as you indicate to us that this number cannot be taken into consideration, then you get all the full marks. Now, there are cases where both answers will be valid, okay? But it all depends on the testing. All right, then we move on to the next question, which is 1.1.4. We have the inequality. So it's x squared. 1.1.4, it's x squared minus x minus 12 is greater than 0. Okay, so inequalities, you just solve them the way you solve normal equations. If we factor this out, we're going to have x minus 4 and x plus 3 is greater or equal to 0. So we need to identify the solutions, which solutions are known as the critical values. Okay, so with those critical values, what do we do? What do we do with the critical values? So we know that x is going to be a 4, and then x is going to be a negative 3. But now remember, this is a parabola. Which parabola is having a smile? So these values are roots, which means you have a -3 and then you have a +4. We are asking for values where the graph is greater than 0, meaning that x needs to be greater than 4 or x needs to be less than -3. Now, after getting your solutions, you need to represent them. Okay, so this is one way of representing the solutions. This is another way of representing the solutions by just drawing the the parabola, and then you indicate those critical values. Okay. Other way is just by a number line. You have your -3, you have your +4, and then you indicate this. Okay, so we have 3 ways of doing that, depending on what the condition is asking for. All right, then we move on to 1.2. So with 1.2, it's a simultaneous equation. It does not always have to be x and y, but it's a norm. It's the culture now that everything must always have x and y. But it could be a p and a q, or r and a t, or any other variables. Okay, so in this case, we have 2 equations. I'm going to baptize this to be equation 1, that to be equation number 2. So between the 2, I see that the first one is more like a quadratic, and then the second one is a linear. So I start with a linear. Okay, I'm going to make y the subject, so it's going to be x plus 3. I'll call this equation 3. Then I'll substitute equation 3 into the first equation. Okay, whatever I make the subject should be substituted into the first, not the second, because we've used the second to obtain the third. So where we have y, we're going to replace it with x plus 3. So we have x squared, okay, plus y squared, and this is the equation of, okay, is equal to 13xy plus 9. And then we say that our y is x plus 3. Okay, so it's going to be x squared plus x plus 3 squared is equal to 13x into x plus 3, and then plus 9. You just need to be smart and systematic so that we avoid any errors, okay? Because one small mistake is going to affect everything up to the end. So that's x squared. When we open this bracket, it's just going to be x squared plus 6x plus 9. When we open here, we have 13x squared plus a 39 plus 9. Okay, let's group everything to one side. Let's take everything to one side. So if I move this to that side, it's going to be, this is 1 and 2, which means I have 11x squared. When this one goes that side, I have a 6x. Does that make sense though? No, man. That's what I'm saying. Let's avoid mistakes. That's a 39x now. And then plus 9, meaning that this is not a 6. It's going to be a 33x. This 9 cancels the 9. Okay, we need to take out what is common, which is the 11x. And I'll have x plus 3. So focusing on the 11x, x is going to be a 0, or x is going to be a -3. Then I will need to get these values of mine and substitute them into the third equation that we got, meaning that y is going to be a 3, or y is going to be a 0. So that is how we would have claimed those 7 marks. Remember, you just have to be consistent and you have to be systematic to obtain all the full marks. All right, then question 1.3. 1.3. For 4 marks, they're telling us that the cube root, this looks otherwise. Okay, so we're saying the cube root of 49 with the exponent of 1010. minus 7 to the exponent of 2019 over 7 to the exponent of 2019. Okay. So whenever we have such questions, create similarity with the bases. Okay, we have a base of 7, this is a base of 49. Know that 49 can be written as 7 squared. So meaning that's going to be these two, that's going to affect the 10, 10 to give us 2020. So 7, 2020, 7, 2019 over 7, 2019. I'll say everything is to the exponent of 1 over 3 because that's the meaning of the cube root. Okay, then factorize out what is common. So 7 to the 2019 is common. Okay, meaning that I'll have 7 just to the exponent of 1, because I know that 1 plus 2019 gives us 2020. Then minus 1 over 7 to the 2019. Everything is to the exponent over third. Did we say minus or plus? Wait a minute, it's a minus, no? It's not going to make sense if it's a minus, because with what I'm seeing. So this is going to cancel that. Then we're going to have a 6 to the exponent of 1 over 3. And then we cannot find the cube root of 6. Unless if the question were to be a plus, then that would make a lot of sense, because now that would be 8, and then the cube root of 8 was going to be a 2. Nevertheless, that's what we get in that case. Okay, then question number 2 for the sequencer series. Okay, geometric, arithmetic, quadratic, all of them. So we have 16, 22, and then 28. They just told us given the sequence, and then they want the formula for the nth term. So before we even find the nth term, we need to determine, is this an arithmetic, quadratic, or basically geometric? Okay, so if this is 16, it's like you add 6 to give you 22. And then if I add 6 again, I'll get a 28. So this is arithmetic. So my A 16, my D is a 6. Okay, so for me to get the nth term from my formula page, to be A plus n minus 1 into D. What's our A? It's going to be 16 plus, we're saying n minus 1 multiplied by 6. So we can open this up. So it's 6n minus 6 plus 16, which means it's just a plus 10. Okay, so that is how we would have gone about that. And then they want us to calculate the 100th term, meaning that tier 100, where there is n, substitute 100. So 6 times 100 plus 10, which becomes 610. All right. Then determine the term of the sequence, which is equal to 310. So this is the Tn. The question wants us to find n, the position. If we substitute into the equation again, it's going to be 310 is equal to 6n plus 10. Let's move the 10 that side. So it's a 310 minus 10 is equal to 6n, meaning that 300, then divide by 6. So n becomes 300 over 6. It becomes 50. So position number 50 is going to have 310. All right, then 2.2. Interesting. We go deeper. The first 3 terms of a quadratic are 8x minus 4x minus 24. This would call for a proper page. Okay, so we have 8. We have x. Okay, we have negative 4. And then we have x minus 24. Okay, remember, they told us it is a quadratic. Okay, so what do we know about a quadratic sequence? We know that it has 2 differences. The first difference that forms an arithmetic, second difference that is constant, okay? meaning that if we are trying to find the first difference, it's going to be T2 minus T1, so x minus 8. If we are finding the first difference, it's going to be negative 4 minus x. If we're looking for that one, it's going to be x minus minus 4, which is x plus 4. Then if we want, sorry about that. Sorry about that. This one is one term. It's not two terms. Okay, meaning that it's going to be x minus 24 plus 4, which is going to be x minus 20. How many terms do we have? It's 1, 2, 3, and 4. 8x, 1, 2, 3, and 4. Okay, then I need to get the second difference here. So it's going to be like negative 4 minus x minus, you put brackets for that, and then here, x minus 20 minus, insert brackets there. Okay, so this is our second difference. So we know that the second difference must always be the same. So I'm going to equate. Is that what the question is asking? Yes, asking for x. So equate the two, meaning that I have negative 4 minus x plus 8 is equal to x minus 20. This and this is a plus 4 plus x. All right, simplify, meaning that we have a negative 2x plus 4 is equal to 2x minus 16. Let's collect the like terms, move the 2 that side, move the 4 that side. So negative 4x is going to be a negative 20, and then x is going to be just a 5. All right, so that is what we are getting, just one value of x. Then if x is a 5, which confirms that, determine the position of the term in the quadratic pattern for which the sum of the first nth term difference will be greater than 300. The sum of the first nth term difference. So we need to get the nth term for the first differences. If our n is a 5, which means it's going to be 5 minus 8, which becomes a negative 3. And then minus 4 minus 5, which is a negative 9. And then 5 minus that is going to be a negative 15. It's a negative 6, a negative 6. Meaning that our Tn, do we need the Tn? Yeah, we need to get the position. So Tn is going to be negative 6n plus, remember we said negative 6n plus a 3. It should be the nth term. Now, if they're talking about something that is greater than 300, because it is the sum that must be greater than 300, let's try to substitute into the formula of the arithmetic sum, n over 2 into, we have 2a plus n minus 1 into t. Okay, so let's see. What are we going to do here? Alternatively, you could also use sum that is greater than negative 3. Okay, we could use n over 2 into a plus l. Okay, so let's just substitute into the first one. I think it's going to be easier. So where there is sum, I'll put my negative 300. And then this is going to be n over 2. 2 times the a, we said our a was a negative 3, which is a negative 6, plus, what is our common difference? Our common difference is a negative 6. Okay, so negative 6n plus 6. So this cancels that. Does that make sense? It should make sense. It should make sense, okay? If we open this up, so okay, negative 300 is equal to negative 6n squared over 2. Did we do anything wrong? I said if this is a negative 6n plus 6. Said 2 times this is negative 6 also. Okay, so I cancel this, I cancel that. I'll be left with just a negative 3n squared is equal to negative 300. N squared is 100, and then the square root is going to be 10. Now, the sum for it to be greater than 300, for which determine the position of the first term. So meaning that is going to be position 11. Okay, so that is position 11. I think that makes a lot of sense if it's position 11. All right, so that is with that question. Question number 3, we have sum to infinity. H is 1, infinity, we have this. Write the first 3 terms of the series, so just substitute. Okay, start with H being a 1. So that's going to be a 0, meaning that my first term is a 4. Then if H is a 2, meaning that I'm going to have 4 multiplied by 0.2x. Okay, from my calculator, if I do the substitution, I'll get a 0.8x. And I know that 0.8 is the same as 4 over 5. Let me just leave it as a common fraction. And then if I replace 3, then it's going to be 0.2, which is 0.04, which means it's going to be 4 over 25, but with x squared. Okay, so those will be the first 3 terms. Then for which values of x will the series converge? Now for convergence, we know that -1 is less r is less 1. Only thing we need to get is our common ratio. So this is T2, this is T1. So divide the 2. Okay, so 4 over 5x, we're dividing it by 4, meaning that my common ratio is 1 over 5x. So I'll say -1 is less x over 5 is less 1. Multiply through by 5. So x must be between -5 and a +5. So that is 3.2. Then they want us to get the sum to infinity just in terms of x. So formula for sum to infinity is just given as that. So our a is a 4 over 1 minus, said our r is x over 5. So that is, okay, when we try to simplify that, it's just going to be 20 over 5 minus x. So this should be our final answer. And then at 3.4, if x is 1, they want us to calculate the smallest number of terms of the series whose sum will differ by less than this from the sum to infinity. Okay, so if we say that sum to infinity is 20 over 5 minus x, they're telling us that if x is a 1, meaning that's going to be 20 over 4, our sum to infinity is just a 5. Okay. Now, if we try to do the substitution to say that sum to infinity minus sum of n terms should be less than 0.001, which is just the same as 1 over 10,000. Okay, let's do the substitution and see. that 5 minus, okay, how would we, okay, how many terms are we focusing on? Determining the number of terms whose series, whose sum will differ. So it's just like the normal sum, which is given as a Rn minus 1 over R minus 1. Okay. So let's see. But we could also use 1 minus Rn, no problem. So 5 minus brackets, our first term is still a 4, okay, into 1 minus 1 over 5 to the n into 1 minus 1 over 5 should be less 0.0001. Okay, so when you do the substitution and the simplification, what are you going to get? Because this is going to give us 4 over 5 when you multiply it through. Okay, because 1 minus 1 over 5, we're going to get just 4 over 5. So let's multiply everything by 4 over 5, by 4 over 5, and then by 4 over 5. So this is going to be 4 minus, this cancels that. Then we shall have a 4. Minus and a minus is a plus 1 over 5 to the exponent of n is less than, this is 0.8. We simplify that. Okay, it's going to be something like 0.28. So this cancels that because 4 minus 4 is a 0. Then we are left with a dilemma. Now there's a 4 here, this 4, and then that 4. Okay, so the dilemma is now to divide both sides by 4. I think now it makes sense. 1 over 5 to the n, and then this is going to be 0.0000 with a 2. But we know that 1 over 5 is the same as 0.2. Okay, so it's the same as 0.2 to the exponent of n is less than 0.1, 2, 3, 4. Then we can use logs. N log of 0.2 is equal to the log of 0, and then you divide both sides by log 0.2. So the n we are getting is that it should be greater than what? N should be greater than 7 for us to get a smaller value, a smaller difference. All right, so that is that. Then question number 4 for the functions. The graph of f is given as that. It's a straight line. And then G is a parabola, drawn A and B are the x-intercepts, and D is the y-intercept. Okay. They want us to get the coordinates of A, B, and K. So A is here, B is here, K is here. Okay, so all of them are intercepts. So by virtue of this, we can start by K. K is going to be a 5, meaning that K is 0 and 5, because the y-intercept. And then for A and B, we know that the graph that is passing there is F and G. We can start by finding the A, or we can just use this equation straight away and factorize. Mean that negative x squared minus 2x minus 15 is equal to 0. Divide through by negative. It's 2x plus 15 is 0. So it's going to be, this is negative. No, this is a positive, meaning that we're going to have a negative here. Okay. Okay, when you open your brackets, we're going to have x minus 3, x plus 5. So either x is going to be a 3 or x is going to be a negative 5. So between A and B, I know that A is going to be negative 5 and 0. Then B is going to be a 3 and 0. Okay, then they want us to get D, which is the y-intercept. So y-intercept is straightforward. the constant. So 0 and 15. Okay. Then they want the coordinates of E. We know that E is just the midpoint or the axis of symmetry. So 4.1.3, axis of symmetry, we can use negative B over 2A, or you can get this and that divided by 2. You'll get the answer. So negative, the B is a negative 2 over 2, the A is a negative 1. So it's going to be 2 over negative 2, which is a negative 1. Then substitute this negative 1 into G. So G of negative 1, it's going to be negative, but negative 1 squared. 2 into a negative 1 plus a 15. What does this give us? Negative 1 plus 2 plus 15. That's 17 minus 1, which becomes a 16. Does that make sense? Nope. Nope. Someone is refusing. Now we can do the substitution once again. But we said our D was a 15. And that is a 16. Well, it makes sense though. Because we said negative and negative 1 squared. Okay. Minus 2 times negative 1. We are adding a 15. So this is a 2, which makes it what? A 17. 17 minus 1 is a 16. Yeah, man. So meaning that D is going to be negative 1 and then a 16. All right. Then they want us to get the range of F. Remember, F is a straight line. Eh? They never gave us any restrictions with the input or domain, meaning that Y should be an element of real numbers. That is enough. Y is an element of real numbers. Because F is a straight line, which makes sense. Okay. Then find the value or values of X where G of X is greater than 0. So G of X is this parabola. Where is it above the x-axis? So between -5 and a +3. So we're just gonna write that as -5 less x less 3. Okay, so that is 4.3. Then 4.4, they want the coordinates of C, the point of intersection of the two graphs. So at point C, both graphs need to be equal to each other, meaning that the negative x squared minus 2x plus 15 should be equated to x plus 5. Okay, let's collect everything on one side, or let's form a standard equation. It's going to be x squared plus 3x minus 10 is equal to 0. Okay, so x plus 5, x minus 2. So either x needs to be at a -5 or x needs to be at a +2. So we saw that -5 is the point A where both graphs meet, and point C is x, where x is what? A 2. Meaning that the y value is going to be 2 plus 5, which is a 7. So meaning that C is 2 and 7. Okay, when you substitute into that equation of F. Okay, if your x is 2, then put the 2 there. Okay, so that is that. Then 4.5, determine the length of EL if EL is parallel to the y-axis. So we know that at this point, x is a -1. And for us to get EL, is just the difference between the graphs. So G minus F. So we're going to say G of x minus F of x. The G is -x squared minus 2x plus 15. We are subtracting x plus 5. Okay, so it's negative x squared minus 2x plus 15 minus x minus 5. Okay, so this represents any distance between the two graphs. You can simplify if you want. So x squared minus 3x plus 10. Then just replace x with a 1. So if x is negative 1, so that is negative 3 into negative 1 plus 10. Simplify this, negative 1 plus 3 plus 10. This gives us 13 minus 1, which is 12 units. So that is the distance between the two graphs for EL. Oh, right. Okay. So that is question 4. Question number 5, we have a hyperbola in this form, and then we have a log function, which is kind of exponential. Okay, so they gave us these conditions, A is K1, and all of that. Okay, vertical asymptote OB is the same as BE. Where is OB? This is O. This is B. It's the same as BE from here up to here, meaning that this is at a 2. Okay, the vertical asymptote D is that. Then C is that. All right, so that's the information we have. Then they want us to find the values of K, D, and P. Okay, so we know that K, where is K? Okay, this is K. Where is D? This is D, that is P. All right, so what do we do? What do we do in that case? Okay, so from our function of f, okay, for us to get a y of 1, x needs to be a 4, okay, meaning that k is going to be a 4 because the log 4 base 4 gives us a 1. Because from our laws of logarithms, for as long as the base and exponents will be the same, then we get a 1. So k is a 4, sorted. Then for us to get this p is the vertical asymptote, which we found here to be 2, because they told us this distance is the same. So meaning that P is going to be a 2. Then we can do the substitution to find D. Okay, using a point. Let's use C, because it's also part of the graph. So where there is Y, I'll put a 0 is equal to D minus 5 over, we said X minus 2. So cross multiply, meaning that D is going to be 5. Okay, so that is how we get those 3 points. And then can we show that the graph G is giving us that? Okay, let's see. So if I'm to rewrite that graph, it's going to be 5 minus x over x minus 2. Okay, that is how it is. Now, how do we move from this form to a form of 3 over x minus 2 minus 1? Okay, so step number 1, we have this. Let's treat this like a normal expression. What we need to do is rewrite or create this denominator on the top. Okay, but when I look at what is already in the top, there's already a disorganization in the arrangement of the numbers and the letter. So you could start by taking out the negative sign. Okay, So if I take out the negative sign, I'll have x minus 5 over x minus 2. Let's have it this way. So it's saying we're going to create a denominator on the top. So negative, we're going to have x minus 2. Okay. So with the x minus 2, what's going to be left to give us a minus 5? It's going to be a minus 3. Okay. I'll close that bracket over x minus 2. Remember I said create a denominator at the top, which is x minus 2. Then what will be left to have this numerator of ours? You subtracted 3. Then from there, do the splitting. We know that a plus c over x is the same as a over x plus c over x. So I'll treat this like one term. So meaning that it's a negative x minus 2 over x minus 2. Negative and negative shall have a plus 3 over x minus 2. So we can already see that this is going to cancel that. You get your negative 1 plus 3 over x minus 2. So this is what the question wanted. So 3 over x minus 2 minus 1. Okay, so that is done. Then write down the image of C if C is reflected above the axis of symmetry. Okay, where is C? And the axis of symmetry of interest is the positive one. Oops, it's this one. Okay, if this is C, which means this is going to be in that other direction. So if we have 5 and 0, the equation is x plus 3, meaning that we are moving this graph some 3 units. Okay, so initially we were supposed to switch positions. Okay, we were supposed to switch the positions, meaning that our x value was going to be 5 minus 3, which gives us what? Yeah, 2. And then for us to get the y value, 0 is equal to x minus 3, meaning that our y value is a 3. So the points of interest supposed to be 3 and 2. Alternatively, what we can say is that if it's 0 plus 3, because of this 3, and then our y value is going to be 5 minus 3 to still give us a 3 and a 2. So that is the point of reflection. Okay, then for which values is f of x? Okay, less or equal to 1 for which values of x? So this is the f of x. When is it below 1? So this is the line of 1. And the x here is a 4. So between 4 and 0. But it's getting into that line. I don't know why. Okay. It's getting into that line of 0, meaning that it cannot be necessarily a 0 as per se. So what we can do, we can start by doing our substitutions if we so wish, but I don't see any need because I already have the 4. Then let me try to, because I need the first value. Okay. So if x is a negative 1, if x is a negative 1, then I'll have 1 over 4. Okay, why is it negative 1? Because our focus was a 1. Less or equal to 1. Okay, so meaning that we're going to have 4 and a quarter. So I'll just simply write it as a quarter is less or equal to x less or equal to 4. Then they want us to get the inverse of f. So from log form to exponential, meaning that's going to be 4 to the exponent of x, because the log is log 4 with x. So this is the inverse. And they want us to write down the domain of the inverse. So if I'm to just look at the technical sketch, if x is a 0, we're going to have a 1. It's an increasing graph. Okay. But now, since they're asking for the domain, x is going to be an element of real numbers. All x values. Then where do we find f of x to be less or equal to 0? Where do we get the negative results? So 1 is below, 1 is above. One is below, 1 is above. Do you see this point at this point 1? And then this point 2. Because one graph is above, the other one is below. The other portion would have been here after 5, because this one is below, that one is above. Okay, so meaning that between 1 and 2. So how do we write that? So 1 is less x and less 2. Now there's an equal sign because with the 1, but then with the 2, there is an asymptote. Since it's 1 mark, yeah, we can have it at that. If it was more than 1 mark, then we could also give this value, that x is greater or equal to 5. Okay, so that is question number 5. Question number 6 is the finance. They're telling us that a car depreciates at 15% per annum compounded annually. How much will the car cost 650,000 5 years ago? How much will a car that cost 655 years ago be worth at the present? So this is reducing balance, because they are saying it compounded annually. So with the reducing balance, we know that A is P into 1 minus I to the exponent of n. So that is 650 is equal to the P into 1 minus. They told us it's 15, which is 0.15 to the exponent of 5. Meaning that P is going to be a 650,000 over 1 minus 0.15 to the exponent of 5. All right, so that is what we just need to put into the calculator. And then we end up with our answer. Okay, so the answer you get here, okay, remember it needs to be smaller than the 650. So let's see. 0, we said 15. 650, I'm getting. Did I say smaller? It's supposed to be more, because remember, it just decreased to this much. Okay, so we're gonna get 1,464,936,26. So 1 million and all those numbers. All right, then 6.2. This person wants to invest 90,000 in 2 separate accounts. Okay, the first one pays interest at 8% per annum compounded monthly, while the other one pays interest rate of 9% per annum. Okay, one is compound, one is simple interest. How much money must he save in each account so that he gets an equal amount? in 6 years. How much must he save in each of the accounts? Now, this is a bit tricky, no? Okay, let's see. Because now we need to compare the compound and then the simple. So with the compound, we know that A is equal to P into 1 plus I to the exponent of N. With the simple, 1 plus IN. They're telling us that both amounts must be the same, okay? How much must save in each account so that he gets an equal amount? So the outcome needs to be the same, meaning that the P into 1 plus I to the exponent of N must be the same as P into 1 plus IN. But is that going to make sense though? How much is he having? He wants to invest in 90,000, meaning that if he invests P amount, whatever is going to be left of the 90 should be sent to that other. So I'm going to say 90,000 minus P into 1 plus IN. Let's do the substitution. This is 1 plus. The interest rate for the compound is 8% monthly. Okay, so it's 0.08 over 12 to the exponent of, for how long? For 6 years now. So times 6. This is 90,000 minus P into 1 plus, the interest rate there is 9% per annum. So 0.09 multiplied by 6. Okay. Let's see if we simplify what we have on the left-hand side, which is just the brackets. We have 1 plus 0.08 over 12 to the exponent of 12 times 6. Okay, I'm getting 1.614p. Okay, when I simplify that bracket first, 0.09 times 6, I'm getting 1.54. Okay, I'll open up. So 1.54 multiplied by 90k, I'm getting 138,600 minus 1.54p. I'm going to move this one to that side. Okay, so 1.54 plus 1.614, which gives me 3.154p, 138,600. Then I'm going to divide both sides by 3.154, divide by 3.154. Okay, so how much was invested initially? 138,600. I'm dividing it by 3.154, which gives me a 43,944,20. Okay, so this was for the compound. And then to get the amount for the simple interest account, it's going to be 90,000 minus 43,944,20. Okay, so 90,000 minus 43,944. I'm getting 46,55,80. So that's how much must invest in the simple, how much must be invested in the compound. All right, so that is how we would have gone about with that question. All right, 6.3. Almost won 5 million in lottery. He decided to invest the money in a bank that gives him an interest rate compounded monthly. If the bank gives him 40,000 as a living wage, calculate the number of months that it will take the bank to pay him back all his money. Okay, so this is a present value situation. Okay, because you're living off money. It's more like living off a loan because it's gonna get finished. It's gonna get to an end. Okay, so if I'm to look at this page, we know that my present value is given as x to 1 minus 1 plus I to the exponent of negative n over I. So our P is 5 million. Okay, our x is 40,000 into 1 minus 1 plus. The interest rate is 8.5 monthly, which is 0.085 over 12 to the exponent of negative 12n. Wait a minute. How many months? So let me just leave it as n, because if I say negative n, which means I'll be looking for the years. Okay, dividing it by 0.085 over 12. Okay, so I'll do my magic. Divide this, and then afterwards I divide that side. So I'm gonna end up with okay, with whatever I'm gonna get, I need to also subtract 1. Okay, why not do this? 5 million times 0.85 over 12. Okay. And then we're saying we are dividing it by 1 over 40,000. Should give us 1 minus 1 plus 0.085 over 12 negative n. When we move this to that side, gonna get a negative answer, which is like a negative 11 over 96 is equal to the negative. When you plus this together, that's a 12 and that. It's gonna simplify itself to 2417 over 2.4 to the negative n. So the negative and negative become positive, and then let's use logs. So meaning that our n is gonna be the negative log. This is the base, 2417 over 2.4. This will be the exponent, 11 over 96. When you simplify that, we are getting 306.93. If I'm to round it off to 2 decimals. Now the question is asking us, calculate the number of months it will take the bank to pay him back all the money. So meaning that instead of us having 306, this guy is gonna get 307 payments, because it's gonna be 306 full payments, and then the last payment is not gonna be full. Okay. Then calculate the outstanding balance for 3 or 6 months. Okay, so with outstanding balance, all we need to do is find the difference between the whatever, the months. So if I were to keep my answers, so the way it was gonna be 306, 9341. I subtract the 306, meaning that we are left with 0.9341, okay, months. So it's a fraction of a month, it's not a full month. So it doesn't qualify to get all the 40,000. So we're going to look for the present value, okay, meaning that I'm gonna use our 40,000 into 1 minus 1 plus the 0.085 over 12. Now to the exponent of this, negative 0.9341. Divide this by 0.085 over 12. Okay, so when you substitute this, we're gonna end up with 3.7, 110.96. So we can see that this is the last payment, which is smaller than the 40,000. All right, so that is to do with the finance. Then question number 7, which is calculus. Now they want us to get this from first principles. So 5x squared from first principles. So one thing we need to know is that if our f of x is 5x squared, we need to find the f of x plus h, which will be 5 into x plus h squared. Then we know that the limit as h tends to 0, f of x plus h minus the f of x divided by h. We do the substitutions. So limit as h tends to 0, 5 into x plus h squared minus our f of x, which is just 5x over h. Limit as h tends to 0, you open that up. So it's going to be x squared, 2xh, h squared minus 5x over h. Okay, open the brackets. We keep the limits flowing. Okay, h tends to 0. 5x squared plus 10xh, 5h squared minus 5x squared. Why am I having just a 5x? So it's supposed to be squared. Okay, so at any one point, the f of x needs to cancel. You're only left with that. So meaning that our next step is the factorization step. Take out the h. Okay, which means you have 10x plus 5h over h. This cancels that. When you substitute h with 0, we're only left with 10x. So that becomes the first principles. Then determine the first derivative f prime of this. So the only tricky part is just the square root, which is already taken care of, meaning that we have 3x squared minus 5x plus. The square root of a square is just that same number, because we know that square root is the same as exponent, a half. Then let's derive this, which means it's going to be 6x, this times that, minus 1. Minus 5 plus 1, because this and this is negative 4x anyway. Why didn't I see that? All right, so that becomes the final answer. Oops, this is a 3, not a 2. Amen. So if that is a 3, which means it's going to be 9x squared. Okay, so 9x squared minus a 4. All right, 7.2.2. We need to factorize what is on the top and then reduce, meaning that it's going to be x minus 4, x plus 2. You're dividing it by x minus 4. This is going to cancel that. And then they want us to find the dx of x plus 2, meaning that our answer is just a 1. We only derive the x because the constant will end up giving us just a 0. Okay, then 7.2.3. Still here, they want the answer with positive exponents. Why are they so strict now? Okay, let's do that. So it's going to be x cubed minus 3. We know that the cube root of x squared is going to be 2 over 3, something like that. Then we take it on top. It's going to be x negative 2 over 3. Then let's find dy dx. The derivative is going to be 3x squared. This and that is going to be a positive 2x. When I subtract 1, it's going to be negative 5 over 3. Okay, that would be my answer. But because of this condition, now I have to take it down. So 3x squared plus 2 over x. You can say x to the 5 over 3, or the cube root of x5, either way. Okay, so that is that. Question number 8, we have the function. If f of x is this, with AC being the turning points, PQ is parallel to the y-axis, they want us to get the coordinates of A. 5 marks. Okay, so we know that A is a turning point. And for us to get the coordinates of the turning point, we have to find the first derivative equated to 0. So our first task is just to open up this, meaning that if I have my 2x minus 1, let me open these last two. So it's x squared plus x minus 3x, which is minus 2x minus 3. Open this up, it's 2x cubed minus 4x squared minus 6x minus x squared plus 2x plus 3. Collect the like terms, 2x cubed minus 5x squared minus 4x plus 3. Then I need to find the first derivative, which is going to be 6x squared. This and that is a minus 10x minus 4. Equate that to 0. So from here, we can divide through by 2, meaning it's 3x squared minus 5x minus 2 is a 0. Open that up, 3x and x. We can have a 2 and a 1 more. That's a 6 minus plus. Nope, it's the other way around. Otherwise, it's not going to make sense. So it's going to be a plus and a minus 6. Okay, meaning that x is negative a third or x is a 2. So between A and C, meaning that A is going to be a 2. Then we're going to get this 2, replace it back into F. It's quite a lot. No? So if I put a 2 here, that's going to be a 3. Put a 2 here, it's going to be a negative 1. Put a 2, it's going to be a 3. Meaning that it's a negative 9. So A is going to be 2 and negative 9. All right, so that will give us 5 marks. No? Then determine the x coordinates of the point of inflection. So with the point of inflection, we need to find the second derivative. So our first derivative is this. Our second is going to be 12x minus 10, equated to 0. So 12x is a 10, divide both sides by 12, which means it's 5/6. Then they want us to sketch the graph of the first derivative, which is a parabola. And now with this parabola, we can see that, okay, let me just sketch it here because I don't want it here. So the roots are 2 and negative a third. So negative a third, and then 2 can be somewhere there. And then all we need is the y-intercept, which is a negative 4. And then you'll have something like that. Okay, so for as long as it's a parabola that is smiling, get your 2 marks. Then write down the values of x for which the first derivative is less than 0, below 0. So we're going to use this. Negative a third is less or equal to x is less or equal to a positive 2. Then if h of x is a 3x plus 1, calculate the value of x for which the length PQ will be maximized. PQ. If h of x is that. If PQ is the perpendicular distance between the two functions. Oh, so this line is called h. Okay. So for us to get the distance between the two, remember, we need to start by subtracting. Which graph is above is the h. Mean that's going to be the 3x plus 1 minus our quadratic, which is 2x cubed minus 5x squared. Okay. Minus 4x plus 3. All right, then open up 3x plus 1 minus 2x cubed plus 5x squared plus 4x minus 3. And like terms, we just collect them. So 5x squared is going to be 7x minus 2. So for us to maximize, which means we have to find the derivative again. And that is 6x squared plus 10x plus 7. Calculate the value of x. Then equate that to 0. 6x squared, so we can divide through by negative if you want. And then we could also use the, what do you call it? The quadratic formula in this case. Because if I see 6x squared plus 10x plus 7 is equal to 0, I'm getting x to be negative 0.53. Oh, my x is going to be 2.2. Okay, so when you look at this line is on the positive side. Okay, remember our x here was a 2, meaning that 2.2 makes sense. So therefore, x is going to be 2.2. All right, so that is how we would have gone about question number 8. Question 9, a piece of rectangular metal with dimensions 60 and 40 is used to create a rectangular box. Square corners of x millimeter are cut out of the metal, and then the edges are folded to form a box without a lid, but with a depth of what? X meters. Sorry, millimeters. What is this? Can we show that the volume of the box is going to be given by this? So they're telling us that if they're cutting off x, now it's fine, forgive my corners, x, they're taking off x and x, and then we have x and x. So what we need to know is that the width is going to be 40 minus 2x. The length is going to be 60 minus 2x. But we've been told that the height is already x, meaning that volume is length times breadth times the height. So we have 60 minus 2x. You're multiplying it by 40 minus 2x, and then the answer multiplied by x. So 40 and 60 is 2.4. This and that is minus 1.2. No, it's actually 120, not 1.2. It's 120x. That is minus 80x plus 4x squared. All of this is inside of x. So 120 and that's a 200. When we open with the x, so it's 2.4x minus 200x squared, and then 4x cubed, which is that. Perfect. And then determine the value of x so that the volume is maximum. We need to find the derivative. So it's 2.4 minus 400x plus 12x squared is equal to 0. We can do the substitution into the calculator because factorizing this is going to be a bit hectic. So I'd rather we use the calculator with the quadratic formula and then find our value of x. Okay, so that is, we said 4. No, it's 2.4. Sorry, 2.4. So either x is going to be a 7.85 or our x is a 25.49. Determine the value of x so that the volume is maximum. Now, as x is millimeters, x represents millimeters. So between the two, because if you cut out more, then the amount of space is going to become whatever. So 7 is a bit reasonable. Why am I saying that? Because there's no way this 25 can fit here. 25 and 25. I mean, we can only obtain a 40. So 7 becomes the most reliable answer, 7,85. 10.1. 10.1. They're telling us that April is deciding on the mode of transport used to go to school. Her choices are motorcycle and a bicycle. So probability of a motorcycle is that, probability of a bicycle is that, time probability that she will decide on a motorcycle or a bicycle. So probability of M or B is going to be probability of M plus the probability of B minus the probability of A and B. But is it possible to use both? No, it's not possible to use both, meaning that this doesn't make sense. The only option is not for her not to use any. Okay, so it's either 0,44 plus 0,55, which becomes a 0,99. All right. And then 10.2, suppose you were promoted the next grade, okay, and you want to pick a classmate. But this works for people that are in grade 11 and below. Okay. So probability that you excel in maths, probability that you're poor in maths. We have the total. Your choices, a sport fanatic or sport bystander, and so on and so forth. 10.2.1, write down the probability that a randomly selected classmate is excellent in maths. So excellent in maths, we don't care whether you're sports fanatic or bystander. We just want excelling in maths, which is a 0,35. Then write down the probability that a randomly selected classmate is a sport bystander. We don't care whether they excel or they not. So this needs to be the 0,75. And then 10.2.3, determine whether a classmate excellence in mathematics is independent of being a bystander in sports participation. So we have the probability. Okay, let's just put it aside. So you excel, and then a bystander. It should be the same as probability of excelling times the probability of bystanding. Okay, so probability of excelling and your bystander is 0,2. Okay, this is what we are having. Probability of excelling is 0,35. Probability of being a bystander is 0,75. Let's multiply what is on the right. If we get the same thing, then we're good to go. So the answer that we're getting is 0,26. Now we can see that 26 is bigger than 0,2. Okay, so in this case, they are not independent. Okay, therefore, not independent. So they can only be independent if the left is equal to the right. Then now 10.3, if we have this word preparatory, the letters are used to form new words. How many different arrangements are possible if letters may not be repeated? Okay, so if we are not repeating any letters, okay, how many letters we have? It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we're going to say that 11 factorial. Then we're going to divide by, because we can see that there are letters that are the same. An example, we have 2 A's. Okay, so that's going to be 2 factorial times 1, 2. We have 2 P's. Okay, which other letters are repeating? The R, 1, 2, 3, which is 3 factorial. So when you divide that, we're going to get 1,663, 200. So those are the different arrangements that we can get. Then 10.3.2, the word must start and end with the same letter. Okay, so with this, 10.3.2, So 2 options, okay? So if they are starting with the same and ending with the same, meaning that we only have 9 letters to choose from, okay? So from the 9, if let's say I've eliminated these 2 that are repeating, I'll be left with 2 factorial times 3 factorial. Plus, the other option is that if I'm dealing with these 3 letter, whatever, reason as to why I'm multiplying by 2 is because we have 2 factorials, okay? So if I'm using the 3 letters, which means the R, starting with R and ending with R, which means I'll just be left with a 1 factorial. So it's gonna be 9 factorial over 2 factorial times a 2 factorial, okay? And when I punch this into my calculator, I'm ending up with 151,200. Then 10.4, they're telling us that South Africa presented 27 male and 11 female athletes in the 2024. Suppose 5 gold medals were won in the athletics. Determine the number of possibilities that the 5 gold medals were won by 3 female and 2 male. So 3 female and then 2 male. So okay, so what we're saying is that if we have 5 people, okay, so we're gonna start with the 3 females, né? Out of the 11, first position is gone. Second position, third position. With the males, we have 27. Can choose from 27 and then 26, meaning that our final result should be 694,980. So these are the ways in which the medals would be won.